Morning, everyone, and welcome to the 42nd ETP4HPC webinar. I am Pascal, ETP4HPC's Communication Manager, and my colleague Gabriela is also here to help run this webinar. So for those of you who are not familiar with ETP4HPC, we are a non-profit association that promotes European research and innovation in HPC, and we are a private member of the EuroHPC JU. So today we are going to talk about Federated Computing Framework. But before we go on to our subject, I would like to share a couple of practical information with you. So this webinar is recorded and you will receive the link to the recording tomorrow. This webinar is in listen-only mode. But there is a number of ways you can communicate with us. I have illustrated it here. So you can ask questions using the question tool. We will handle all of your questions at the end of the webinar, but you can submit a question at any time. You can download handouts. Today we have put the slides here, and as well as the draft white paper that we are going to talk about today. Yeah, that's about it. And there is another way you can communicate with us today, and that's special. We have created a Mentimeter session so we can get some feedback from you on specific questions. So we have prepared 4 questions for you in Mentimeter, and you can see here how to join. Go to menti.com and enter this code. The code is also in the chat. So I encourage you to go there right away because I have prepared a warm-up question for you and it's already open. So please go to Mentimeter. I will just show the agenda and welcome our speakers. So Sai, maybe you can say a word about today's topic while we answer the Mentimeter warm-up question.
Sure, Pascal. Yeah. Good morning, everyone. So very exciting to have this webinar. So just to give you a context, the SRA 6 was released in January. And as part of that, we also released 14 backing white papers along with our SRA 6 master. So now, during the past 1 year, our team has worked on so-called agile white papers, where we go deeper into certain specific topics of interest for the community as well as for the policymakers. So the topics that we have looked at in the past year are federation, workflows, storage and I/O for AI, and energy efficiency and the status of SMEs. So we had the research workflows discussion in the last webinar. So today we'll go a bit deeper into the Federation computing platforms, and we have some of our experts from the European community here on the call. I'm very pleased to have them. So yeah, I mean, without further ado, I think we can go a bit deeper into the Federation topics, and we very much welcome the feedback from you all on what you think the priority should be for this area. Yeah.
Okay, we have 10 people who joined the Mentimeter session, so I'm sure we can do better. So the question will remain open, and I will go on to, sorry. I will go on to today's presentation. If I can find it. Oh my God. Sorry. Sorry, I'll be right with you. Small technical problem. Where is it? Ah. Sorry, it's not working. We rehearsed and it's not working.
It's a demo effect, don't worry.
Yeah,
yeah.
I know.
Yeah, take your time, Pascal. I think it should be fine.
Yeah. Here we are.
Yeah,
Yeah, you can see the screen now. Yeah, it's fine, Pascal.
I take
So,
over from here,
yeah,
Pascal.
yeah.
Okay, so thanks for the introduction. My name is Fabrizio Magogliani, and with the other colleagues, Hans Christian Hoppe and Henrik Nortamo, will present the work that we have been doing about the Federated Computing Framework and how this concept is paving the way to the European-wide collaboration among the different data centers and other institutions. Next one. Okay, first of all, let's try to set the stage or frame what we are going to discuss. The first item is, next one, Pascal. A brief introduction of the speakers. I won't go through any single line, but you have a sort of parterre du roi, as Pascal may say. So we have the best speakers about the specific subjects. Next one. Okay. Now, I'm sure that the question you're asking is why we need this white paper. Well, the basic reason is the fact that the concept of a federation platform infrastructure or framework is critical for the success of a coordinated and homogeneous set of systems. As we know, the European Union, through EuroHPC, has been investing in significant computational resources. And it makes a lot of sense to coordinate the access and the usage of these resources for different scientific and engineering requirements. This is providing a huge set of opportunities, but at the same time is rising some, I don't want to call them problems, but for sure some something that we could must be addressed, let's say that. Okay, and this webinar is, and the related white paper is focused in sharing what is our current thinking and get input and any other comments from the audience. Next one. Okay. Thanks a lot. Of course, this webinar is aligned with the scope of ETP4HPC Strategic Research Agenda, and it is providing a complete framework of what the different options are for the best exploitation of the system. Last but not least, we will provide also some R&I, R&I recommendations, which will help the EuroHPC and Horizon Europe to set the guidelines for the future calls and projects. Next one. The white paper has the following structure. Hans Christian will present the state of the art as as it is right now, and showing the need to harmonize between different items like the tier 1, 0 to 1, and 2. And then we will have Henrik presenting the EuroHPC Federation Platform Initiative. And we thanks a lot, Henrik, for being here. Last but not least, we will present the recommendations. Next one. First of all, we should agree about what a Federation Computing Infrastructure is, because as you may know, there are several different definitions for this, and we define the Federation Computing Infrastructure as the implementation and operation of a suite of technologies and functionalities targeted at the coordinated management and interoperability of data, resources, and processes across different systems, location, and organization boundaries. Of course, this is creating and managing an interconnect between different systems, and also provides a sort of framework for organizations to collaborate and share resources without giving us full control and access to the users, and maintaining a sort of selectable level of autonomy. Before moving forward, I think we have a question about if this definition is good, or is wow, that's
Yeah, people,
good.
I mean, the question has been open since we displayed this slide, so
Okay.
people have started answering. So please go to your phones and join the Mentimeter session if you have not already. If you have not joined, the instructions on how to join are in the chat. The code number is in the chat.
So I will pause a couple of seconds to let people vote.
They agree
So
with you overall.
well, yes, well, it depends if the top of it is 5 or
Unless
is
you've been
10.
answering.
So the top is 5, I assume, Pascal, is not 10.
Yeah.
Otherwise, we are in trouble.
No.
Okay, it stabilized. So I feel that at least 80% of the people is aligned with this definition. That's a first and a very good point, because it shows that we are shooting in the right direction.
Okay, just let me know when you want to go back to your slide.
Go back to the slide.
Okay. Thank you, everyone, for taking part.
Okay, good. Next one, Pascal. Okay.
Yes.
Now I leave the stage to Hans Christian for the current HPC-centric federation landscape. Hans Christian.
Yeah, thank you, Fabrizio. So can you advance the slide, Pascal? So the next 3 slides, I will try to give a 64,000 feet view of what we currently have in the EU with regards to federation for HPC-centric users. Of course, the Euro HPC JU Federation, that will be presented by Henrik after my part. So this is not included yet. So I have been actually working in HPC for a very, very, very long time. And so I remember when the Federation of HPC Centers first came up, end of the 90s, and it has been that long since it happened. At that time, this was called grid computing, since the centers would form a computational grid. and users would be able to access the grid at any one of the participating centers and then use the resources of all the centers in a nice, effective and efficient way. So out of this initial initiative, so there were two leading developments that came out. One was called Unicore. That was developed in Europe, actually first in Germany and then at a European scale. And I was very much involved in that all these years back. Parts are still in use. And this is not necessarily a very good message, since it is a system where active development has stopped around 10 years ago. The other one, of course, and that is known to many more people, is the Globus effort. Globus Toolkit was the latest incarnation that was started at Argonne National Labs in the US, and that has seen a lot of take up and has basically all disappeared, except, similar to Unicore, in a use for data transfer. In addition, in the 2000s, we had a real actual standardization body, the Global or Open Grid Forum, that looked at all the questions of federation. And if you still have access to the old documents, they have basically looked into all the topics that we are still discussing. But they have been doing this in a very, very different technology landscape, since in the end of the 90s, beginning of the 2000s, virtualization was known as a concept and implementations were there, but it was totally and utterly unusable for HPC, since it was slowing down computers, it presented difficulties to access high-performance networks. So virtualization was not really looked at, and there was lots of cleverness invested to hide the differences of systems without being able to virtualize. So that's the ancient history. The important thing is that this has actually triggered significant developments since, and these are two kinds of developments. And a lot of the, at least European work on more modern federation systems was triggered by domains, certain scientific domains and scientific communities. Two of the examples that I will go into a little bit of detail 2 slides away are the worldwide the Worldwide Computing Grid, WLCG, from CERN, and that has its root, of course, in high energy physics, in the Large Hadron Collider, and the need of these physics scientists to exchange vast amounts of data and to run high throughput computing on them. The other one is Phoenix, which was started out as a more general purpose federation, but was adopted and then driven in its development by the Human Brain Flagship Initiative. Some of you might remember this, and is being used in the brain science community. There are others, and well, I mentioned a few systems, and this is not a judgment of that they are better than the other ones that I don't mention, but we had to take a pick. So these specific science domain systems have done amazing things, and they're being used by a lot of scientists in their day-to-day work. Multidisciplinary systems have also been coming up, but usually they were sequed off one of the domain specific solutions. And the one that I want to talk a bit more about is the EGI Federation. I'd like to mention also CSCS in Switzerland. They're not part of Euro HPC JU, but for Switzerland, they have come up with their own hands-on and very well functioning way of federating their resources. So that's also worthwhile to look at. What do we have today in Europe? Well, of course, we know we have the Euro HPC ecosystem, lots of systems, some of them really the largest in the world, but a lot of leading edge systems. But there's more. First thing is there's high performance computing, and then there is what is sometimes called high throughput computing. High performance computing uses or relies on applications that run on dozens, hundreds, thousands of compute nodes at the same time, and that need to have support from a very good interconnect network. HTC uses well, at least as many nodes, but there the applications are more local. So what we see today in Europe are at least 3 tiers of systems. Tier 0, and that is of course Euro HPC JU with most of their systems. Places like CERN, huge systems, tier one huge systems that also have global or pan-European use. Then there are significant tier one systems, and I've just mentioned three: Jancy in France, NHR in Germany, and the Supercomputation in Spain. And these include some of the leading edge systems, but also smaller systems, and they are more targeted towards national use, but they are very, very important for science. So they should not be overlooked. And then, of course, we have tier two, and these are hundreds, thousands of universities and research centers. What has happened if you look at federation, there is the concept of federating in one of these tiers. And some of the efforts have actually federated across tiers. And what is, at least if you look from the side of the European scientific communities, necessary is to have federation systems that can actually involve several of these tiers. Next slide, please. So if you're talking, that's the usual problem with fonts. The headline is broken in a suboptimal way. But anyway, so this table, and well, it's actually readable on GoTo. I'm amazed. So this table has entries that show some or most of the functionality that a federation layer has to provide. And that also then has some remarks on the technology that we're currently seeing used. If you go from top to bottom, we start with user administration and accounting of what the users do on the system. And of course, we know Linux is used everywhere. So all the local Linux ways to manage user IDs and quotas and accounting is being used. And this is usually actually the accounting is different by center. There are really wide differences in what they do. For a federation, of course, you need to have an abstract user management with some kind of single sign-on because, well, there's a person that signs on and it doesn't matter what kind of cryptic user ID he or she has across the various centers. And accounting has to be done in a way that the use of resources is converted to some kind of common currency and then summed up. There are systems, and I'll just mention one called Valdur that are developed in Europe, in the Baltic states, that promise to do this. But this is definitely an area to watch. If you have federation and then people still would need to allocate budgets in local currencies at the various centers, and then they would need to be very careful on how much shekels they have left in one center and how much dollar they have left in another center, virtual dollar, of course, this will be tricky. Then, of course, there is secure compute, access to compute and data. So we know that SSL-based ways like SSH and SCP are used universally. There are advanced file transfer systems. FTS is the one done by CERN and WLCG. UFTP is the Unicode one. Rucho is a scientific data management system because besides transferring, you need to be able to manage data, make it findable by scientists. Single sign-on, well, there are a couple of established technologies. I've mentioned three, and they again rely on standards, industry standards. So that is relatively solid. Challenges that we see in current systems are more around policies and around, well, getting the various participating centers to use a common method and to accept it. Then policies, of course, basically two ways. You write access requests and, well, the federation actually reviews them and you get access or you get part of what you've requested. Or you get access because you're part of a project that has put in money into, or virtual money, pledged resources into a federation. And both methods are valid. Probably you can't unify them. Resource management and scheduling, coming from an HPC board like myself. Well, Slurm right now is the incumbent used by almost everybody. There are some other schedulers around. But HPC with the need to juggle middle-sized and very large jobs and really build ahead schedules that allow you to use systems efficiently is only part of the story. OpenStack based, more flexible resource management and scheduling, like for instance implemented by Kubernetes. This is really being used in the AI field and in the HTC field. So Ideally, we would find a way to drive both. I've put up Flux here as the great white hope to maybe in a few years to replace Slurm by something that is more accessible and more dynamic. Federations need to find a way to actually support these two different methods, batch and task scheduling, and also hide the differences. Plus, there is the need, or at least the desire, to do hierarchical or meta scheduling. I'm showing my age by using meta scheduling here. And there were, during, well, all these years that I was working on the topic, many projects, many good technology, but this is really an interesting part and also a little bit, I would say, a researchy part of the evolution we see, for instance, with EuroHPC JU. An important topic that sometimes federation systems say it's not for us, somebody else has to do it, but in my view, it should be in there. Well, we have it relatively easy in that basically all the systems use Linux, and well, if you know the Linux shell and if you know the important commands and if you know how to drive a compiler, well, you're all set up. But for a lot of scientific users, there's still very many details that they need to learn if they go to a new platform or if they switch to a new center, and that of course gets in the way. And if you do development of software for science or for industry, then of course you're facing now an increasing diversity in architectures, in particular since we have accelerators now being de rigueur in HPC and HTC, and accelerators do not at all agree on how they should be programmed. And more annoyingly, we see the concept of walled gardens that are only being supported and available on a single vendor's accelerators. That has made a resurgence. What is very important if you say you have a federated infrastructure and you have different architectures in this infrastructure is to also think about how can you hide or obstruct these differences. Portability, higher level services, higher level frameworks come to mind. Workflows are a topic that always comes up, and science today is based on workflows and not on working through 25 shell commands in a sequence. This is automated in workflows. The point in federation technologies is if you study the workflow field, you will find that there are too many systems. There's a huge amount of systems, and that has been the case for more than 10 years now. There are attempts to actually create standards. CWL, Common Workflow Language, is an established one, but there are other competing ones. What we need to do in federation is we need to find a middle ground to support the relevant and important workflow systems. We cannot support all of them because there are too many, just too many, and more are being written basically every month. Ideally, one could focus on a single standard like CWL, and then all the systems that can drive CWL downstream would be supported. But this is not the case right now. And of course, if you do meta scheduling and if you want to do automatic resource discovery, that also has to be built in. And then finally, higher level services. So say for an engineer in an industrial company that wants to run a structural simulation, they do not want to edit input files. They do not want to use Emacs or VI or what have you. They want to have a nice portal interface where they just dial in where the model descriptions are, what kind of boundary conditions they want to see, and then submit it. And this is something that is increasingly taken up. On the software development side, basically computer scientists have been talking since that term was invented about high-level domain-specific languages and how do we help the domain scientists to be very efficient. Actually, the first such systems that I've been seeing that really work and are being taken up are the AI frameworks, and they may show a way for the future that should be taken. Last slide, please. Okay, comes on. So that slide here has 4 elements. One is a shameless plug to a project at the bottom called Spectrum that has done a pretty thorough study of what's there regarding federation systems and what scientific communities want. So I give the link, and these studies should be published by now. And well, in the interest of full disclosure, I was part of writing these. So 3 different systems: WLCG, which is, well, just the basic for the Large Hadron Collider, all the science around it, and for other science in high energy physics that uses accelerated data. This has been built up over decades, currently serves, well, about 12,000 scientists, 170 institutes. The important thing is here, it serves them in their day-to-day work. It is not something that they use, oh, I fancy to do something different this week. It is the backbone of that work. And it makes data available, so it covers data federation, it covers compute federation. Most of the compute is high throughput computing, but they also do significant high performance computing, like for simulating their accelerator devices. They also, the EGI one has actually adopted token-based authentication. There's an AARC working group organization that codifies authentication methods. So they're not using X509 certificates at all. The interesting thing here is WLCG, since it's a circumscribed field, it's a large field, but still it is self-similar. So they could actually create very good high-level interfaces, tools, and frameworks to aid the physicists. So this is really, really, really far advanced. They have a good automated resource discovery and workflow engine based on HD Condor, which is a relatively old system again from the US, but this is being used day to day on thousands of systems. They also have interesting concepts for data management. That's called Ruscio here. And then for data transfer, FTS is an very, very advanced data transfer framework, I should say. So basically, you can specify source and destination. You can specify the SLA. Well, how quickly do you need that? And the system figures out how to do it. And it could also decide to transfer from a different source if it knows that there is some mirror deployed. So this is really at a much higher level than doing FTP, SCP, or all of the others. The middle one is derived from Phoenix. It's now part of the eBrains organization and project. And this is brain research, 8,000 scientists. Well, this comes because it was a basis of the Human Brain Project. This is HPC and data. They use MyAccessID, which is also absolutely established way. SSH access, but also advanced data access. One of the interesting differentiating elements here is that they have a part of their data, a part of their storage functionality and of their storage infrastructure actually can store and keep health data safe, implementing GDPR to the full. High energy physics don't do that, and a lot of the open science data doesn't care and doesn't have any personal data. Here, this is the holy grail of personal data, health and medicine data. So eBrains has figured out a way how to do this and integrate it with predominantly open science federation infrastructure. It could be interesting to see how they do this. Again, high-level interfaces. They're very, very strong on data catalogs and location services. So if a brain scientist needs certain brain connection data, it's easy to find that. And this is based on CWL. So they take a standards approach. They say workflows that have a CWL backend can run, period. And then the last one is EGI. That's an organization in the Netherlands. And this is segued from WLCG quite a while ago. This is now general purpose cross-domain. They have a very high count of users, 100,000. But these are typically project users, and these are users that come and go. And it's not necessarily the same as for the first two, which are really backing up important parts of science. EGI is supporting projects. Also important, they come from HTC, but embracing HPC now. They use a similar approach to WLCG on authentication. And they differentiate in that they also, besides the HPC style Slurm batch processing, they offer OpenStack/Kubernetes kind of task or of resource management task scheduling. Interesting thing also here is that EGI reaches out to, or as backends can use cloud service providers, the Amazons, the Microsofts of this world, if the projects that actually join EGI and that say, well, we need these resources, can pay for it, but they can act as an intermediate layer, hiding the cloud service providers. Otherwise, they work with more scientific or publicly funded resources through HD Condor and ARC. So that's what I had prepared for you. I hope it is useful. More is contained in the white paper or then in the deliverables of Spectrum.
Thanks a lot,
You have
Hans
Pascal.
Christian. Go on.
Perfect.
So Henrik, the
I can
floor is
start.
yours.
Thank you very much. Okay, so hi Henrik. I'm
Oops,
Henrik.
sorry.
Thank you. I lead the technical work for the EuroHPC Federation platform. And as it already has come up, so the EuroHPC is funding and owning very many systems now across the Europe. Currently uncounted 9 online HP systems with 3 just around the corner, 19 AI factories, some overlap with the HPC systems, and then at least 10 quantum systems. I wouldn't be surprised if there's more in the future. Next slide, please. And of course, the current kind of issue towards the user, be that academia or industry, who want to be able to quickly move between systems or just quickly get access, is that the onboarding process for each now about 30 system is fully separate. Once you have access, the credential and the accounts are fully separate. I have currently probably 6 or 7 different accounts on various EuroHPC systems. Invest in a good password manager. Your project management is also fully separate, which is fine for your research group of 3 people or your 2-person startup. But then if you're a large research infrastructure and you have 150 people, manually keeping track on those on 5 different systems is, let's say, error prone. And of course, for actually doing things, the way you access the systems, the interfaces, and how you handle the credentials is different, essentially meaning that you need to redo a bunch of work. Next. So the solution we're currently developing now here, owned also by the EuroHPC, is the so-called EuroHPC Federation platform, which the kind of very high-level vision for being the one-stop shop for gaining access and then utilizing these EuroHPC systems and all the distinct and individual services they provide. At its core, the platform will provide the aforementioned federated identity and single sign-on. So essentially, same institutional or even national EID provided identity across all the systems. One place to manage allocations over multiple systems or multiple projects over multiple systems, with then managing who's in them, who can access what. What I would like to call a pseudo unified software offering. So of course, not the holy grail of all software works everywhere, but a very solid baseline of the same software on all the federated system, which helps in migrating workloads and especially getting started, or will actually get you across the finish line if, again, performance isn't your, let's say, leading star there. And then to make things easier, we are on top of these kind of core software identity and allocations, providing advanced graphical interfaces for creation and managing workflows, doing interactive computing, or then various other domain-specific graphical tools. Most AI researchers prefer a notebook, so if we can throw them in a notebook with 500,000 worth of GPUs on the node, why not do that? And then with an emphasis on the novice users. So again, we're constantly seeing not everyone who needs to do compute or needs to do research, innovation, or growing a business know how to use Linux or the command line, and we're kind of past the point where we need to force them to use that. Of course, we're not dumbing down things. The idea is also to federate the access to all the direct access and all the APIs that all the individual systems are anyhow providing. So then it's up to the individual user to choose which interface suits their workflows or ways of working the best. And then on top of that, we are adding these kind of smart scheduling capabilities to raise the level of abstraction on where things could be scheduled on run, either automatically or then as suggestions that, hey, we've noticed that one of the systems you have access to is now underutilized. Go there for way lower queuing times. Next slide, please. So conceptually, how it works is there is a platform, there is a web interface where people can authenticate and they can register. Now, via this web interface, they can gain access to all of the systems and then use the high-level features, or then they can fetch credentials to be used directly, be that SSH, provisioning OpenStack, Kubernetes, or any kind of, let's say, an AI inference service offered by an AI factory. And of course, the compute part is important, but that doesn't cover the whole end-to-end work people are doing. So the EFP platform is also connected to the then review platform, which was also mentioned. So essentially this kind of end-to-end automation that once you have been granted resource, it just flows to the system and you get an email that, hey, you can now SSH into a tier 0 supercomputer. Here, follow the instructions. Instead of sending 5 people 5 images of your passport and scanning something and signing that and other, let's say, slowdowns. And then it's also going to be connected to European data federations, so that again you could have a common shared identity to actually then ingest and export the data you are producing on the supercomputers. Next slide, please. So 3 following slides, these are just screenshots of our development environments. So this is essentially your landing page to the Federation platform where you get an overview of everything's going on. You have this many workflows somewhere. These are your interactive sessions, and here you find more information on your projects. Did anything happen? Did you get a credential? And so on. Next slide. This would be the interface for managing your allocations. So seeing who's in what of your project, how much of the resources have you consumed on what system, and so on. This is all mock data, so no need to worry about the GDPR. But here we can, for example, see that we have several mock projects on Mare Nostrum 5 or Vega, and they can have then essentially an arbitrary configuration of resources, or then if somebody gets really excited, it could be just credits all the way down, but currently it's more kind of a static resource model. Next. And this would be a screenshot of our interactive component, where essentially we'll provide you a set of graphical applications and then provide you automation to launch that on a specific system or in a specific queue, or then through the smart scheduling capability coming later. If you don't specifically care where you are doing some mock thing, we can just throw you somewhere. Some of the highlighting things here we're coming with is Visual Studio Code for code development, of course, Jupyter Notebooks for AI, MLflow for following training, and then graphical desktops for people who want to more kind of the desktop-like experience on some of the resources. Next slide. So our timeline is that we started this project in January 25. And we're currently in our first phase, both developing all our internal functionalities and in heavy collaboration with all the EuroHPC centers to get our things integrated. And the goal is that by end of March next year, we'll have the basic functionality on the currently online EuroHPC systems. That would be 9 systems in total. And then you will be able, once granted an allocation on any of the integrated EuroHPC system, gain access through the EFP and manage your projects, get access, launch interactive jobs or workflows. And then subsequent releases will kind of bring more high-level features, more polished features, and then of course more systems. There is a very large backlog of the URHP systems coming online at some point. And currently this is a total of 5-year project with the last 3 years, again, bringing in more systems, and most probably based on the feedback we'll be gathering from stakeholders and people actually using the systems, improving or feature enhancements. Next slide. And very shortly, some of the insights now regards to the Federation, that it is very well to know when to standardize and when differences are a strength. You want the same user onboarding. You don't want the same queue on every system. That doesn't make sense. These kind of things require a very high degree of flexibility because we do need to connect currently 12 very different systems and plan for being able to cost efficiently and quickly connect 20 new systems, 30 new systems, 50 new systems, national URHPC gives. We don't own anything we're federating, which means that any kind of solution has to be very non-invasive. Otherwise, I mean, people having operational responsibility of that infrastructure would not be very happy to deploy that. And of course, highlighting in a federated nature, the most important factor is trust and security, because federation fundamentally requires trusting some external information and giving them some capability to delegate on your behalf. Thanks.
Thank you. Back to you, Fabrizio. Thank you, Henrik.
And really thanks to all the speakers that have provided a very smart view of what the status is and what the objectives and achievement of the URHPC Federated platform are. We have achieved all these good results up to now, but there are some upcoming challenges in front of us. Next slide, thanks. The team has identified the following key challenges for achieving an effective and usable federated computing infrastructure. The first one is interoperability. As also Henrik has mentioned, the Federation Computing Infrastructure has to be designed from scratch to enable the interaction and interactivity across different systems with different technology protocols and standards. This is going to be key. Providing interoperability means providing usable system across the board. And also it should include the portability layers. Covering the various CPU accelerator architectures. So just making sure that all the different architecture are going to be exploited with the proper application layer. The second is the federation of data. We know that data are as important as compute. Therefore, there should be the services for federation of data and interact with the other data infrastructure across all the different platforms. It's not bringing data to the compute, it's bringing compute to the data now. Third, but not below the others, is data security and sovereignty. Potentially, the systems are going to be used for some critical computational, either in healthcare or for any other domain. Anyway, the Federation provide extreme, well-based data protection, data security, and privacy preserving computational. It is a mandatory. We think that the mechanisms are provided to enforce check and control security policies across the different infrastructure. Last but not least is openness. we know that we will have different systems, different architecture, different ways of assessing the resource. Therefore, openness of the ability to embed different architectures is going to be key for providing access to the resource and make sure that only the authorized user are actually using the system. Drilling a bit. Next slide, Pascal. Thanks. We know that there are some other challenges like how move data and how to move efficiently data. We know that that data are always growing, and the CERN or the SKA initiatives are showing that in the future we will have multi-terabyte data that has to be moved. This is something that the Federation platform should take into account in the development. Next, how to too fast, Pascal. How to enable the data sharing restrictions across the different systems. Proprietary data may hinder the collaboration and lower the performance. We will have more and more different systems with different protocols, different way of assessing cloud, like and different system. We have to make sure that in the Federation platform, we will be able to provide efficient access to these different resources and also embed from the scratch, from the beginning, as a key element, the architectural diversity and prevent that any different architecture may hinder the full exploitation of the resources, as well as making sure that the structure is not frozen in time and space, but will be able to extend to other resources. And we know that the different systems that will be part of the Federation may have totally different features that the current and the big future will be the agentic AI, how using agentic AI could enable the efficient exploitation of resources, or how can we put in place some agentic AI to make sure that, that there is a smart allocation of resources. Next one. Drilling down, the white paper is reporting the different areas for which the team has been devising some strategies as well as some thoughts. And I want to raise here the point that we should learn from the previous lessons, most of all from the cloud orchestration, which can bear very well to the efficient design of the Federation systems, as well as integrated, as Henrik mentioned, quantum computing resources, which have totally different technologies, as well as totally different timescales. So beyond the traditional phenomenon style resources, we will have to take into account in the Federation also these new technologies, which present a sort of range of challenges of their own. Next one. Also, the resource management automation tools has to be developed properly. And in this moment, as Hans Christian and Heinrich mentioned, there is a lack of uniform abstraction layer across the different layers of the infrastructure, and that should be harmonized or at least made interoperability. And as mentioned before, the identification and the classification of the resources across the different continuum is going to be key, as well as failure detection and recovery. The larger the system is, the more statistically provided fault that may take place. Therefore, we have to put in place a sort of mechanism to recover from any faulty system and make sure that the system is continuously working, no matter what the degradation is going to be. Next slide. Now, given the fact that we have seen the challenges, let's see the recommendation and conclusions. Next slides. The team has identified this recommendation. The first one is to be absolutely ready to explore the new technologies and how these new technologies can be integrated in the current infrastructure. We mentioned quantum, but also other technologies like neuromorphic or data gathering device should be part of the federation. Moreover, the co-design between users and the data centers is going to be key. We know that to grow, we have to set some expectations as well as set the proper framework for what to develop. Therefore, co-design, including the objectives, KPI, and metrics should be developed between all the stakeholders of the federation infrastructures, as well as take interoperability at the next stage and enabling all the current technologies and infrastructure to be interoperable with also the new mobile communication standards, enabling therefore having different sources of data to be embedded naturally embedded in the framework. Next slide. As Henrik has mentioned, we have to enable the dynamic integration of future AI infrastructure, AI factories, as well as gigafactories, as well as the private infrastructure, which may be included in the network. And let me spend a word about making sure that the usage of the federation infrastructure is user-friendly. Any very difficult to use or unfriendly interface is preventing the large exploitation of the infrastructure. And last but not least, data security, data access, authorization control is going to be key. We cannot afford to have unrestricted access to these resources. We have to make sure that all the authorized users can access the system. And we have to provide also tools to let the management of the infrastructure know whether there are unauthorized accesses. Next slide. The team is keen to think that a financial model for dealing with licensed software is going to be key, because that's it's providing either a source of financing as well as preventing any legal controversies between the infrastructure and the licensed software, the ISVs, basically. And also, communication and dissemination is going to be critical. In this moment, the Federation is still not completely known by the masses, if you understand what I mean. Therefore, a very capillary operation for advertising the benefits of using the infrastructure is not only increasing the number of users, which is always good, but also increasing the value of the developments that will be done on this infrastructure. Next slide. Let's come to the conclusions. We have seen that the Federation Computing Infrastructure is providing several key benefits to the scientific engineering communities, and is key for increasing the competitiveness of the European ecosystem. We have seen that in this moment we have the ability to provide resources to the right people at the right moment, and with the proper level of security. And the fact that we have to harvest the full benefits of the computing is a indication that we have to make a cross-organizational collaboration and the standardization effort to create a fully operative system. So we are on the right tracks in this moment. Next slide. And I close this part with a mention to a well-known word. It's with great power comes great responsibility. So in this moment, we are setting the frame to make our Europe more competitive in terms of scientific and industrial ecosystem, and it is entirely upon us to make sure that this benefit will be put into the hands of our users. With this, I think I'm done with the presentation, and I think there are a couple of questions I've seen.
Yeah, so
Okay.
I'm going to. How about the Mentimeter questions?
Oh,
Shall
sorry,
I
go.
display them?
Yeah. Is my mobile, sorry.
No, now it's on your. So the first Mentimeter question was, how do you rate the importance of federated platform
Yeah.
following an open source approach?
Yeah.
And while people are answering this, we can also have a look at the questions that came in. They are in the chat. So there is a question from Andrea Manzi. Will the EuroHPC Federation provide also bulk data transfer between the systems? This one is probably for Henrik.
Yes, I answer that one. Hope it's visible to everyone, but I can. Yes, bulk data transfer is an explicit feature also included in the minimum viable product. Then specifically how performant that bulk data transfer is will mostly depend on the data transfer capabilities at the different federation targets. So we're kind of using what's there, not increasing any capabilities, but I have high hopes that, for example, the newly published hyperconnectivity call, which will build actual better networks between the different EuroHPC systems, will hopefully complete the second half of this transfer, so the interfaces and the actual raw technical capability to move around bits.
Okay, thank you. Fabrizio, did you want to comment on the Mentimeter result or?
Yes, 4.7 out of 5 is very good. So therefore,
Yeah.
this is reinstating the fact that the open approach is something that has to be embedded in the development of the federation. Yes, thanks a lot.
Okay. Shall I go on to the next Mentimeter question?
Yes, please. I know that we are 5 minutes
Oh, this
late.
one is, yeah, I know we're running late, but
Yeah.
are the
Well,
research and innovation recommendations realistic?
I won't vote because otherwise
No,
I'm a bit skewed in
you can't
this.
vote. Okay. While people are voting, can we maybe have a look at the next question from our audience? There is a question from Thierry Goubier. Will the constraints of the portability layer of the Computing Federation help or restrict the introduction of new HPC technologies, new types of AI accelerators, for example? Who takes that one?
Well, I take it. Thanks, Thierry, for the question. It give us food for thoughts. My opinion, but that's my opinion, of course, is the fact that we have to work to embed in the picture the new types of accelerators. And we have to make sure that there won't be any constraints in this moment to embed these new types of accelerators. I mean, it is mostly in our hands what is going to happen. So we will take into account your recommendations and make sure that there won't be any restrictions. I know that this statement looks like wishful thinking, but as I mentioned before, it is in our hands to how to move forward and what to make the federation.
Okay. In the meantime, we don't have too much participation from Mentimeter. Please use your smartphone. So if I look at the evaluation, well, it's realistic, but not fully realistic, Fabio, if
Yes,
I may say so.
it's a 5 out of 5, so 80%.
Yeah.
So it's not very realistic. The audience does not believe it is realistic. Okay.
Yeah. Okay. I'll go on to the last Mentimeter question, if that's okay for you.
Yeah.
And so this is where you, audience, are expected to enter your thoughts. So please join at menti.com and use the code shown on the screen. And there is another question from the audience. So question from Fabio Liberti. Is it possible to study these systems up close, or postdoc or temporal visiting positions possible?
I take this, any analysis or further deepening of the system are welcome because it will help understand how these systems are reacting or should be designed for. About the postdoc or temporal visiting positioning, that should be specific either to the data centers or to the vendors implementing the federation. Therefore, I point to you, Fabio, to check with the single data centers and the vendors if there are any position in this moment for studying the federation.
Okay, we have some answers. So Fabio, can you see the answer in the Mentimeter? It's on the screen.
I
Role
see
of
the screen.
advanced
Yeah.
networks. and communication channels as part of the Federation platform needs to be better understood, especially for bulk data transfer.
Can you capture these messages, Pascal, somehow without
Yes, I
merely
will. I
taking the
will.
screenshot?
Yes, I will have
Okay.
them. I will share them
Okay.
with you once we're done.
Okay. That's a good
Okay.
advice.
Any other question, Gabriela? Do you see any other question or
No, no other
There,
questions.
there is another posting. Any thoughts on software distribution policies, external network connectivity from the worker nodes? Okay, thanks a
Generally
lot for this
speaking,
input.
yes, I can comment on the second question. Generally speaking, prefer to design the system you can work without that. It's kind of some places allow outboard connectivity, some don't. And that's kind of different. Infrastructures have different security considerations. So it's, and then if you can't work without outbound connectivity, then it's better to just choose systems which do offer that.
Yeah, maybe I can say something to the first question. So one thing, of course, is in the draft, there is a section on networks, next generation networks and 6G. But also, if you look at Euro HPC JU and the EU Commission, so there was a project that actually created a large study on connectivity, what is required for HPC in Europe. There has been a procurement to actually secure commensurate network connections. And as far as I know, also the procurement has been decided. So there is, in reality, there is significant work, significant effort being expended to further improve the networks that we have in Europe across, the various sites. So this is actually being done. We didn't really touch on this in this presentation. That is true, in the interest of time.
Okay, well, I think as we are running very late now, we will close for today. I would like to thank our audience. If you have more thoughts to share about this webinar, you can still email us at webinar@etp4hpc.eu. That's the contact address mentioned in the webinar invitation you received, and we will transmit to whoever is to Fabio and the team. I would like to thank our speakers, of course. Thank you, Hans Christian. Thank you, Henrik. And special thanks to Fabrizio, because it's night time where he is currently. So he's a big thank you to you, Fabrizio, for doing. Thank you,
My
Gabriela,
pleasure.
for handling the questions. And thank you, Sai. And
Thank you, everyone.
we hope
Welcome.
to see you again at our next webinar. It's not announced yet, but we'll have another webinar probably at the end of November. We are trying to organize a special session based on the BOF session that we are organizing at SC 25. So I think it's going to be different, but very interesting. And we will let you know. As you know, anybody who attends one of our webinar will receive the invitation to the next webinar. So thank you again, and talk to you in November, I hope. Bye-bye.
Okay. See you,
Bye.
everyone.
Thanks,
Bye-bye.
everybody.
Bye.
Bye.
Bye.